Welcome to this training module on PowerShoot Network Shutdown version 4.1 software for VMware. This training presentation explains how PowerShoot Network Shutdown software works in conjunction with your APC UPS to protect your physical and virtual IT infrastructure from adverse power events. This e-learning is structured as follows. For those of you not familiar with PowerShoot, this module first provides an introduction to the software's capabilities before providing a high-level overview of how PowerShoot works. We will then discuss the benefits of deploying PowerShoot Network Shutdown in a VMware environment, including the range of options available. Following this, a technical demo will show you how to configure PowerShoot to support a VMware high-availability cluster before showcasing PowerShoot Network Shutdown, protecting your VMware architecture during a power outage. At the end of this module, you will know how the software works, how to deploy PowerShoot to protect your VMware environment, and understand PowerShoot's flexibility, ease of integration, and configuration for VMware. PowerShoot Network Shutdown works in conjunction with the APC UPS Network Management Card to protect your physical and virtual IT infrastructure from adverse power events. The software is widely deployed in server rooms, data centers, branch offices, network closets, and distributed networks to protect IT equipment during a power outage, minimizing time to recovery. Single, redundant, parallel, and advanced redundant UPS configurations are supported. This first diagram shows a standard single UPS with a network management card inserted in the smart slot protecting 3 servers, each with a PowerShoot Network Shutdown agent installed. The UPS network management card sends status updates every 20 seconds to each PowerShoot agent, or immediately if there is a state change such as the UPS goes on battery. PowerShoot will then initiate actions such as running a command file or starting a shutdown sequence depending on the nature of the UPS update and how PowerShoot is configured. As mentioned previously, PowerShoot Network Shutdown supports the following UPS configurations. Single UPS configuration, a single UPS protecting 1 or more servers. Redundant UPS configuration, up to 4 UPSs configured in a redundant UPS configuration, supporting 1 or more servers. Each UPS has the capacity to supply power to the load on its own. The first UPS provides all the power for the load. The additional UPSs act as reserve. Parallel UPS configuration. PowerShoot Network Shutdown recognizes that the UPSs are set up in a parallel configuration and will monitor the changing load on the UPSs to manage how UPS events are aggregated, depending on the level of redundancy in the system at any given time. And Advanced UPS configuration. The Advanced UPS configuration enables a single PowerShoot Network Shutdown agent to monitor multiple UPS setups and initiate graceful shutdown based on different redundancy levels. Each UPS setup can be a single UPS or a UPS group of 2 or more UPSs. PowerShoot Network Shutdown is certified VMware ready and provides an extensive range of options to suit your VMware availability and power protection requirements. Virtual machine migration options. During a power outage or other UPS critical event, PowerShoot can migrate virtual machines to other available hosts, either in the same cluster or to available hosts at a different geographical location. You can also select the specific host that virtual machines get migrated to for greater control. Lastly, PowerShoot Network Shutdown version 4.1 provides the option to control the order that virtual machines are migrated in. Extensive graceful shutdown capabilities. The new virtual machine prioritization feature in PowerShoot version 4.1 also allows you to control the order the VMs are shut down and powered on in. PowerShoot also supports the graceful shutdown of VMware vApps if they are present in your VMware cluster, and lastly, will safely shut down your VMware hosts in the event of an extended power outage. Ease of deployment and management. To simplify the installation and deployment, PowerShoot can be deployed as a VMware virtual appliance, which can be downloaded from the APC website. Our focus on usability means features such as the graphical representation of your virtual cluster environment and UPS setup has made configuration as seamless as possible by providing an intuitive view of your UPS and host configuration on a single screen. Lastly, the vSphere plugin option integrates PowerShoot with vCenter Server for ease of management, enabling PowerShoot monitoring with the vSphere client. Plugin options are available for either the vSphere desktop client or web client, as seen here. PowerShoot Network Shutdown is the only power protection software that migrates virtual machines without leveraging VMware's Distributed Resource Scheduler technology, or DRS technology. PowerShoot is capable of migrating VMs to multiple available hosts across clusters and can also protect the vCenter server when it's running on a virtual machine. All of these capabilities make APC PowerChute Network Shutdown the industry leader when it comes to protecting your VMware environment. We are now going to move on to a technical demonstration of how you can configure PowerChute in a VMware environment. Before we launch the PowerChute Setup Wizard, here is an overview of the environment you need to protect. UPSs number 1 and number 2 are configured in a redundant UPS configuration protecting the storage array and physical machine running PowerChute. The UPSs are connected to 2 separate power supplies. Your HA cluster contains 4 VMware hosts running virtual machines. UPS number 3 protects hosts A and B, while UPS number 4 protects hosts C and D. vCenter Server is running as a VM on host A. UPS number 3 is connected to power supply number 1, and UPS number 4 is connected to power supply number 2. After installing PowerChute, the user is presented with the step-by-step PowerChute Setup Wizard. For today's demo, I am just going to demonstrate the VMware configuration steps. Let's start by clicking on the Next button. PowerChute supports 2 VMware configuration options. Number 1, standalone VMware host, and number 2, VMware hosts managed by vCenter Server. In my configuration, the VMware hosts are managed by vCenter Server, so I select this option. This is how we configure PowerChute to communicate with vCenter Server. The customer enters their vCenter Server IP address for FQDN followed by their vCenter Server username and password. For this demo, vCenter Server is running on a VM, so we enable this option. When this option is selected, PowerChute performs additional validation tasks to ensure it can locate the vCenter Server virtual machine. On the UPS configuration page, we select Advanced UPS Configuration, which enables us to enter details for all our UPSs in the setup. We then add our UPS setups on the UPS Details page. I will first enter the details of the UPS protecting my physical machine, running PowerChute, and the storage array. As this is a redundant configuration, I select UPS Group. I then add the UPS setup name and IP addresses of the network management card inserted in each UPS. We then add the UPSs protecting each of the ESXi hosts. In this setup, host group A single UPS is protecting the ESXi hosts, so we select this option and add the network management card IP address. 2 single UPSs are powering the 4 hosts in the cluster, and 2 UPSs in a redundant configuration are protecting the storage array and physical machine running Powershoot. In Powershoot, we display the ESXi hosts in a tree view structure that mirrors how they are displayed in vCenter. You can see how the hosts displayed in the left panel of the previous screen mirror what is displayed in vCenter. The right panel displays the UPS setups that were configured earlier. The next step is to link the ESXi hosts with the UPSs they are powered by. We can do this by simply dragging the hosts from the left and dropping them under the appropriate UPS in the right panel. It is possible to select multiple hosts at a time. We don't link any hosts to the UPS powering the physical Powershoot machine and storage array. The next section that must be completed is Virtualization Settings screen. The Virtualization Settings screen allows you to define what actions we want to perform on the virtual machines in the event of a power outage or other UPS critical event. Enable VM migration allows VMs to migrate to other hosts that are unaffected by a power outage. For each action selected, you need to enter a value in the duration field, which is the time allowed for the specific action to complete. VM Shutdown Startup. VM Shutdown is selected by default. By enabling VM Startup, Powershoot will automatically power on any VMs that were shut down after the UPS critical event has been resolved. Powershoot also supports gracefully shutting down VMware vApps, which we have not selected for this demo. Powershoot automatically detects if vCenter server is running on a VM, and if so, then this option is automatically enabled. The vCenter server VM will be shut down after all other VMs. The default duration of 4 minutes can be changed based on the customer's environment. Powershoot provides plug-in options for the vSphere desktop and web client. Enabling this option integrates Powershoot directly with vCenter server. Click Next to complete the setup, and you are brought to the main UI. By default, Powershoot will only shut down on the UPS low battery condition. You can select additional events to trigger a shutdown sequence by clicking on Configure Events. For this demo, we will enable shutdown for a UPS on battery event. Here I have defined a shutdown delay of 300 seconds, which is the amount of time the UPS is allowed to run on battery before Powershoot initiates the shutdown sequence. Powershoot Network Shutdown provides a virtual machine prioritization feature which allows you to control the order that cluster VMs are migrated, shut down, and powered on in. In the left panel, all the virtual machines in the vCenter inventory are represented, which again mirrors the display in the vCenter. On the right-hand side, you have 3 priority groups: high, medium, and low. We categorize the VMs by selecting them on the left and dragging them to the required group on the right. Any VMs not grouped are considered unprioritized. It is possible to select multiple VMs at the same time. For VM migration, You then define the required time for each priority group to complete the migration task. You can then skip migration for lower priority groups by setting a 0-second duration. For example, you may not want to migrate low priority or unprioritized VMs. For VM shutdown duration, a value greater than 0 must be added for any group containing VMs, otherwise there would not be enough time for them to shut down gracefully. You are unable to proceed without configuring these duration values. Finally, we have the option to set the VM startup duration for each priority group. Similar to migration, you can choose to skip powering on some lower priority virtual machines by specifying a 0-second duration, and these VMs will not be restarted. To save the settings, click the Apply button. To access the Powershoot vSphere web client plugin, click on Home. Then select the Powershoot icon. You can then directly access the Powershoot UI via the vCenter plugin. To enter Powershoot Network Shutdown, start by entering your username and password. We will now demonstrate prioritized VM migration and a graceful shutdown sequence in action. We will trigger a power outage on the UPSs connected to mains power supply 1. This will affect the UPSs in host group A and one of the UPSs powering the storage array Powershoot machine. We trigger a power outage on the UPSs connected to one of the mains power supplies. This will affect the UPSs in host group A and one of the UPSs powering the storage array and Powershoot machine. Only one UPS in the redundant configuration protecting the physical machine and storage array is on battery. Therefore, no shutdown sequence is triggered for this equipment. For this demo, we have categorized the virtual machines by adding them to high, medium, and low priority groups. This allows us to control the order that VMs will be migrated and shut down when a critical UPS event occurs. High priority VMs are migrated first, followed by medium priority VMs after 180 seconds. Low and unprioritized VMs will not be migrated since there is a 0-second delay configured for these groups. VMs are shut down in the following order: unprioritized, low, medium, high. The values represent the time allowed to shut down VMs in each priority group before moving to the next group. In this demo, Powershoot will shut down unprioritized VMs first, wait 30 seconds, and then start shutting down low priority VMs. After 60 seconds, Powershoot starts shutting down medium priority VMs. After another 60 seconds, Powershoot shuts down the high priority VMs. For this demo, we have enabled the shutdown action for the UPS on battery event. We set the shutdown delay to 120 seconds, so after the UPS has been running on battery power for 2 minutes, Powershoot will start the shutdown sequence. Powershoot has detected a power outage and records that the UPSs are running on battery power. After the shutdown delay has elapsed, Powershoot initiates a shutdown sequence on the ESXi hosts in Group A. No shutdown sequence is triggered on the Powershoot machine because it is a redundant UPS configuration. Powershoot starts a maintenance mode task on each affected host and then begins to migrate VMs to the hosts that are not impacted by the power outage. Here we see Powershoot migrating the high-priority VMs first. Note, Powershoot vCenter server warning alarm is triggered for affected hosts when a critical event occurs, as shown here. After the VM migration duration for the high-priority VMs has elapsed, Powershoot migrates the medium priority VMs. Low priority VMs are not migrated. Note, one high priority VM and one medium priority VM could not be migrated. These will be safely shut down later. Reasons why a virtual machine may not be migrated include target hosts are not compatible, or the host does not have sufficient resources. Powershoot proceeds with the VM shutdown step, starting with the low priority VMs. After the duration for low priority VMs has elapsed, Powershoot shuts down medium priority VMs. After the duration for medium priority VMs has elapsed, Powershoot shuts down high priority VMs. All VMs have been gracefully shut down or migrated. The hosts are now in maintenance mode. Once the VM shutdown timers have elapsed, Powershoot proceeds to safely shut down the two ESXi hosts. The Powershoot vCenter alarm status changes from warning to critical, triggered when host shutdown command is sent. Hosts have been safely shut down and show not responding state in vCenter server since they are now powered off. You have now reached the end of this e-learning module. To learn more, you can go to the product pages on apc.com to access online materials including application notes and user guides. You can also download the software directly from the software/firmware downloads link on the APC homepage.